value, type int double. So I'm going to make this into a range of from minimal value to maximum value. So times maximum value minus, because that's the range, and then adding that range to my minimum value. Great. So this should give me random number between 2 to 8. If you want this to be bigger, 2 to 11. Yeah, so that's fine. You can always change this 2 to 10. And I'm going to use this as my radiuses. So radiuses should be also a list all radiuses as a double. I'm going to use that as my input value as well. So okay, so let all of them to have radiuses. And before you calculate, so here anything should be together. So radiuses, my radiuses plus, oops, my neighbor radius that should be okay now. Yeah, it's working. So that's how you can add different radiuses for each of them. But now there's something wrong with this calculation. I'm sure it's a little thing. So let me fix that. Let me fix it. I can fix it. Maybe you can have a break while I fix this. Or try to catch up by writing this or something. Does this sound okay? Give me like 5 minutes.
Yes.
Figure out what's wrong. Hmm?
Yeah, 5 minutes break.
Yeah.
That's good. Yeah.
Oh, I know. I figured out. So I need to have a bracket here. So there was a problem. Now it's working fine. So, okay, so this line was, I missed the bracket here. So I should have minus this one and then divide by 5. Like if I miss this bracket, it calculates differently. It divides, it minuses the half the distance. Was it okay? Let me know. So this is actually working fine for me. We set break, so you can tell me if we can start. But like only thing was wrong was this bracket calculation. So on number 79. So I'm going to actually hide everything else. Delete. Let me know whenever you want to start, yeah? Yeah, what do you mean by going through? Like I explain it again? This script is pretty, yeah, pretty short, you can notice. This doesn't involve any class, so the structure is not really integrated. But that's why, therefore, it's pretty simple. So basically, you are getting the starting position and the radiuses, and they all have same coherent number. So if you have hundreds of starting position, you have hundreds of radiuses. That is determined from here in the beginning. We are using same number here to create 116 points, 116 random numbers, all right? And in the set, if we say reset, this all centers will be refreshed with the start positions. So they will become starting positions. So they will get refreshed. And then otherwise, this is storing, this is setting up, so getting ready for them to move. So in order to move, each point should have a vector, and this is a setup for this to be ready to calculate that vector. That vector is added at the end of this script. So you want to see that there are 3 steps here. So these 3 steps. So this is set up the circle agents. This is the actual calculation. Actual calculation computing based on their neighbors. And this is finally adding movement vector to position. What does 0.0 means? What do you mean? Where? Here? Which line? Okay, it's fine. You can ask me any question. Are you unable to unmute yourself because of the host didn't allow you or something? Okay. I unmuted you, so you can speak if you need any question. No, I can't. Line 76. So you want me to explain you line 76? So line 76 is calculating the distance from center I to center J. So we are looping through all of these points one by one. That is I 0, 1, 2, 3, 4. And then inside this, I'm comparing myself with other. That's why I'm looping through all of them again. That's why the J is inside I'm comparing. So basically, if you have 100, the calculation becomes 10,000 times, because 100 by 100. So what it does is from here, I calculate my neighbor, all of them. And you go through all of them. And then once this is done, I calculate from this one, I calculate all my neighbors one by one. I do that all for all of them. And then I go to this one and compare with everything. And then this one, everything. That's why I loop through I first. And then inside I loop through J. So J means my neighbors, and I is my current calculation agent. Does this make sense? So basically, I is calculating the distance to J. And if my distance with my neighbor is smaller than where we should be, then I do this. Otherwise, I don't have to. If they're far enough, I don't have to consider them, isn't it? So only when they have collision, it means my center is colliding. So I need to move like that. And I need to ask my neighbor to move like that. So that's what's happening here. It's not many lines. You can try to sit down and try to understand line by line. It makes quite a lot of sense. Yeah. And this actually works. So can we move on?
Yeah, I think so.
Okay. Okay, cool. So I think the circle packing script is usable and it's working. So we will kind of pause it here instead of like adding more complexities there. Circle packing. But now I'm going to just go through a little bit of how to maybe use it in a way you saw from my samples. But this one can be easily now translated to 3D. So because you can have a three-dimensional starting point, and then you can refresh it and start the animation. And they are actually finding their three-dimensional position. It's just now we are drawing a circle, but if you draw a sphere, for example, using the point base plane and radius, and they are actually finding their own position. So you can see. Yeah, so this actually is very easy or like fastest way of making a sphere packed meaningful kind of geometry. You can actually what I was how I was using this with students is to orient my geometry according to the vectors also from what the vector set is creating. So basically, just in order to use this, I'm going to just hide them. I'm going to move it back to 2D. Okay. All right, so what I need is their vector as well. So instead of just using their center, I'm going to also export the total moves, yeah? So the total moves can be also, let's say if we can have it underneath here. So we can have it here. And say total moves. So we are executing the vector as well. So now what we can actually show is not only the points, but also the vectors. By using vector display, the anchor are the center and the movement vector is that. But you see that it works according to their movement. It was really huge. So I'm going to just unitize it. So make these vectors into unit vector. You will see that they will all snap to a unit. So you remember it was starting really big, but now you don't have that anymore. And what I'm going to do is I'm going to just scale that according to my radius. Scale that by just multiplying it. This I'm just doing it for visibility, so that's why I'm not going inside my script. So you can also make it as a scripted, so it's less geometry. So that vector, and I'm going to use that vector to do something, for example. So basically, what I'm going to do is I modeled a small geometry. Looks like that. If I go to a shading view, it's just a really simple mesh. And what I'm going to do is I'm going to orient this according to these vectors. So if you use orient direction, you can orient a geometry. So whatever breadth. So in our case, we are using a mesh input. And you need the origin point to center it. So I'm going to just input it, like using an origin point, PT. So I have this point. So I orient from this point. Do you know how orient works? In Rhino, orient means orient. Orient means you can grab 2 points and start to copy to different places. So we are going to do that by scripting it, right? So as you can see that you need a point, 2 points in Rhino, but here it actually means you need one starting point and the direction. So what I'm going to put is a vector pointing to X. So you can say X unit X, or you can just say, you can add a panel and say 1, 0, 0. You can specify a vector like this. You can change to multi-data. So this and this is same, but I'm going to maybe use this one just for an example. And the P is where you want to orient this to. So you want to use all these points. So now they all are oriented to that point. And because this is pointing to Z, so that's why it's going up. But we are going to use these vectors. That's why we can use these vectors. This will actually scale this as well. So you'll notice that they all got scaled because this starts from 1. So we are actually going to use that unit vector instead. So they're all oriented there, but they didn't get scaled. So you notice that they are also moving, but it's actually better if they are scaled more correctly. So basically what you want to do is you want these geometries to be within 1, 1, 1 a bounding box. So let's draw a box 0, 0, 0 and make it into 1, 1, and 1. Okay, I'm going to pause this a bit, and I'm going to move this, move 0, 0, 0. Scale this, scale. So if this is within this bounding box, this will scale together with this thing. So now I can use this vector instead of the z vector. So you see that now this is scaled according to your radius. So because now this is perfectly 1, that's why it snaps to this 1 position. So if if you understand this relationship, you can scale this thing according to what you want. So I'm going to hide this. I'm going to hide this for now. And you can actually move this around. So it's actually according to, so you understand that this will become your radius. So let me just draw a point here. So this will be oriented according to your position, like within this thing, right? So you can scale this thing also around this, so they are actually scaled more fully around. If you want this to be even a bit bigger, to be able to snap or kind of interlock with their neighbor, you can also overscale this a bit as well. So this one is now snapped to the geometry, and you can actually change the visibilities of this so it's more obvious. So you can change from here. So whatever is unselected, maybe you can make the visibility to gray. You can also use the preview mesh, so make it more visible. Of course, you can change it to render view and use this as a preview. You can use custom preview and use the geometry. So you can use a mesh, use a color swatch, for example. Something it's more obvious. So something like that. So you can create some intricate or interesting walls system, for example. You can also easily make this into 3D. So let's try to make it into 3D, but you will see that they will get rotated everywhere, like that. So they are rotating everywhere. That is kind of quite difficult to use. So in this case, you probably want to snap the orientation to a certain axis, yeah. But before that, I just want to change the scale a little bit because I think it's a bit too big. So disable. Okay, I think this one can be scale. Okay, so I scaled it down a little bit. Okay, so you notice that this orientation is there's nothing you can actually change because it's quite fixed. There is another thing called Orient, just Orient, but it also doesn't really let you control. It just moves from one point to the other. So if you can see what it does. Yeah, it only does that, like moving things there. So at least this one actually scales it for you. So if we want to actually have some more control, I really suggest you rebuild this in C#. But there are a few more lines, and Actually, transform is a bit more sophisticated math. So I just